Algebra Unit 8, Lesson 6, Note 6, Factoring Trinomials, where your A term is greater than 1. When factoring trinomials with the leading coefficient, greater than 1, we can use a combination of the factoring trinomial method and factor by grouping method. This can be accomplished by splitting the middle term of the trinomial. As before, the trinomial must be in standard form first. So, the best way to, of course, explain this to you is by showing you. There's, in the key concept box over here, you can read through it, but really it won't make sense to you until you see it happen. So factor each trinomial. If it can't be factored, write prime. And remember, we always want to check for GCF first. You want to make sure there's no greatest common factor. If there is, we need to pull it absolutely first. When you factor anything, you always must check for GCF. Okay. So I would look at your trinomial. So we have 3x squared plus 16x plus 5. It is in fact in standard form. And if I look at those three terms, there is not a GCF I can pull out. Okay. So I taught my students how to do a method called MAM. Some of you just learned a similar thing, you just didn't necessarily use the acronym MAM. So I'll do a brief explanation of it in case you do not know what it is. So when I'm in standard form in a trinomial, I write the acronym MAM above it in order. M stands for multiply and A stands for add. So we multiply the first and last two terms together. So 3 times 5 is 15. So the M value is 15, and the A value is positive 16. And I want to find factors of 15 that add up to 16. So 3 times 5 comes to mind. 3 times 5 is 15, but when I add them, they equal 8. They don't work. I also can do 1 and 15. They multiply to be 15, and when I add them, they do in fact equal 16. If you didn't learn the MAM method, you would have just learned to create some sort of table or think about it in your head, what multiply together to be 15, but also add to be 16. Same concept, I just made it a little more concrete and visual. Okay, so this is different from trinomials where the coefficient is 1 in that I do not just write x plus 1, x plus 15. That won't work, okay? And it won't work because if I were to FOIL this, x times x, I would only get x squared, and I have a 3x squared. So what we can do with this information instead is we can take the middle term, which is 16x, and we can split it. And we're going to split it by making it an addition problem. 1x plus 15x, okay? And that came from over here, the 1 and the 15. The rest of it I want you to bring down, 3x squared plus, and then the plus 5 at the end. So basically what I'm doing, when my leading coefficient isn't 1, I'm making this a 4-term polynomial. And when we have 4-term polynomials, we can factor by grouping. So now look at your first grouping. And it doesn't matter which order you put it in. You could have put the 15x here and the 1x here. It doesn't matter. It will always work. Your work would be a little bit different, but you would end up with the same result. So in this one, it looks like we have an x in common, leaving 3x plus 1. In the second grouping, we can pull out a positive 5, which leaves 3x plus 1. So I have 3x plus 1 and x plus 5. So we used a combination of our MAM method and our factor by grouping method to factor these type of trinomials. Let's do another simple one. Let's look at letter B. It is in descending order already, standard form. There is no GCF, so I can go ahead. I'm again going to use my method, MAM, but if you used a different method, go ahead and use it. The M is 14, and the A is -9. Well, I have positive 14 and negative 9. So positive 14 would be 2 and 7, but when I add them together, it's positive 9. To get that negative 9, I need both of these to be negative, because remember, a negative times a negative equals a positive. And then when I add them, it gets me the negative 9 that I need. Remember, your leading coefficient isn't 1. So when we have that, we have to split the middle term. So the first term is 2x squared. I'm going to split the middle term by using negative 2 and negative 7. So negative 2x, negative 7x, and then bring down your last term. We're going to group, again remembering to group in that sign before the 7x. In my first grouping, I have a 2x in common, which leaves me x minus 1. And in the second grouping, I have a 7 in common, but again, I want you to notice I have a plus here and a minus here. If I want to make this minus, I have to pull out a negative. So I'm going to pull out a negative 7, which would change this term to a positive x and this term to a negative 1. Leaving my factored form as x minus 1 times 2x minus 7. Again, you can write it the other way, 2x minus 7 times x minus 1, because multiplication is commutative. Let's jump down to f. Okay, I need it in standard form. So 5x squared plus 3x plus 4. Check for a GCF, in which there isn't one. And I'm going to label it ma'am. M is 20, A is 3. Okay, I've got factors of 20, 1 and 20, which add to be 21. I have 2 and 10, which equal 12. 3 doesn't go into it. 4 and 5. When I add them, it equals 9. Now, I could also do negatives, but what's going to happen is I'm just going to get those same sums except for the opposites. So again, I could write them all out if I wanted to. I would get negative 12 here, and then negative 4 and negative 5 would be negative 9. None of them are 3. I have exhausted all the factors of 20. None of them add to be 3, which means this is prime. It can't be factored. You must make sure you go through all the factors before you determine it's prime. There might be something there that you're forgetting, okay? When you are struggling, don't just assume it's prime because you can't think of something, okay? Make sure you go through all of them. I like to go in order when I do them. I always start with the 1, then 2 goes into it. I noticed 3 doesn't go into it, so I skipped it. 4 goes into it, and notice how 4 and 5 are factors, okay? And they're 1 away from each other, so I know I'm done. I kind of closed that gap, because if I did 5, it would be 4, it'd be the same thing. So I knew I had all my factors. Jump to letter J. I'm in standard form, and I do not have a GCF. So I'm going to use my method. M is negative 12 this time, and A is negative 11. Okay, to make negative 12, I could do negative 4 times positive 3. When I add them, I get negative 1. That's too far away. So let's try a larger factor. Let's try negative 12. So negative 12 times positive 1 gives me negative 12. And when I add them, I get negative 11. Okay, again, I'm splitting the middle term. So the first term is 4r squared. I'm splitting the middle term into negative 12r and positive 1r. And then I'm bringing down my last term. I'm going to group now that I have 4 terms. I can pull out a 4r from the first grouping, and I'm left with r minus 3. And I already have r minus 3, but I'm going to pull out that positive 1 so I remember to put it in my answer. And I have r minus 3. So r minus 3 is the common binomial, and then the leftovers for r plus 1. Let's jump down to L. Okay, letter L. I am in descending order, which is great. However, there is a GCF. Notice how they're all even numbers, 4, 38, and 70. I can definitely pull out a 2. A 4 doesn't go into 38 or 70, so I can't pull out a 4. But I can pull out a 2. You must pull out a GCF first, if you have it. When I pull out the 2, I am left with 2w squared plus 19w plus 35. Not only, another good reason to pull out the GCF is it makes your numbers smaller on the inside of your parentheses, which makes it a little bit easier to find factors, okay? Okay, we're going to ignore this 2 for now, but we're going to come back to it later, okay? Don't forget about it. I'm going to label ma'am. The M is 70, and the A is 19. Okay, well, I have 7 and 10, which adds to be 17. Let's start at the beginning. I have 1 and 70. That's 71, too far away. 2 goes into it. 2 times 35, which gives us 37. 3 doesn't go into it. 4 doesn't. 5 definitely does. Let me use the calculator here. 70 divided by 5 gives us 14. And that equals 19. And that's our winner there. Okay, again, we're ignoring this 2 for now. We'll come back to it. So I'm going to bring down my first term, 2w squared, splitting my middle term into positive 5w and positive 14w, and bring down the 35. Let's go ahead and group. The only thing in common in this first one is a w, and I'm left with 2w plus 5. And in the second grouping, I have a 7 in common, which leaves me 2w plus 5. So I would have 2w plus 5, and the leftovers w plus 7. Did you forget about the 2 from before? That 2, you just bring it down. So you actually have 3 factors for this trinomial. I will tell you that letter M also has a GCF to help you out there, okay? I want you to finish the rest on your own. I will tell you that there are, looks like 1, 2, 3, 4 answers, including the one that I gave you, that are prime. So you only have 3 more answers on here that will be prime. So be careful. Make sure you exhaust all the factors before you decide it's prime.